Welcome to the REWIRE Expert Interview Series, in which we talk about security within IoT environments in the context of Zero Trust Systems of Systems. REWIRE is a visionary 3-year project funded by the European Commission under the Horizon Europe program. The project envisions a holistic security management framework to safeguard complex IoT ecosystems during the whole spectrum of their life cycle, from the design to the runtime phases. My name is Christiana Kiperunda from 8bells, one of the partners of the REWIRE consortium, and I am delighted to introduce our expert for our fourth interview, Manolis Surligas from the Libre Space Foundation, one of the technical partners and use case leaders of the REWIRE project. Welcome, Manolis, and thank you very much for joining me today.
Thank you.
Can you please explain what is the most urgent problem in cybersecurity research that we are trying to solve in REWIRE?
So yes, mainly with Libre Space Foundation, we are involved in projects of small satellites, and we're targeting the CubeSats. So in CubeSats, security is not the primary concern due to the limited resources on board the satellite. But nowadays satellites are becoming a commodity, let's say. So we have seen cases that security starts to be an issue even in those small satellites. We would like to pinpoint, let's say, the aspect of security in the domain of CubeSats. So REWIRE could be a perfect, let's say, candidate as a showcase for the security aspect on CubeSats.
In this context, we are driving the integration of the REWIRE security solutions in a safety-critical application domain, as this of secure satellites. So can you please summarize the core challenges that you are investigating, for instance, trade-offs between security versus safety, security versus trust, security versus usability? How all these have been taken into consideration in REWIRE?
Yeah, this is a good question. So mainly we try to see the security aspect on the CubeSat domain as for the over-the-air update. So over-the-air update is a very critical component of CubeSat mission, because you cannot access the satellite as it is deployed in space. So the only way to fix bugs or improve the functionality of the satellite is with an over-the-air update. So if you have the way to update your satellite, it has to be secure, because somehow a non-legitimate user may upload a firmware that is not trusted and take over your satellite. So this is a very important aspect that has to be, let's say, secured or assured that it is safe and will operate as expected, and will perform by legitimate only operators on the ground.
Thus, security is not a standalone problem in the satellites domain, as in most of today's autonomous systems. The desire for the satellite to be more efficient, more secure, has driven trends across the industry towards concepts such as remote maintenance and software updates. What does this entail, and how REWIRE trusted computing helps towards this direction?
Yeah, so I will just describe our vision, let's say, how we would like such a system to operate. In a such scenario, the mission operator, which is located in the ground, should initiate an over-the-air update to the satellite, and a system like REWIRE could take over and do behind the scenes anything is required in order to assure that this firmware will reach the satellite, will be tested on the satellite prior any kind of booting on the new firmware. assuring that is correct and from a legitimate mission operator, and then apply it. And if something goes wrong, a process of rollback to the previous legitimate firmware could take place in order to ensure that the satellite availability is not disrupted.
Could you explain us the philosophy behind integrating trusted computing, attestation services, and in general secure lifecycle management mechanism and how they can help overcome any security challenges in the supply chain of the satellite industry?
Yeah, this is a quite complex system, huh? But in general, we can split the system into parts. The operations that are performed on the ground, and some operations that are operated on the satellite. This has to be these two different um, execution environments should be somehow unified. REWIRE has the mechanisms to do that. So there is a separate there are separate mechanisms and services that are run on the infrastructure of REWIRE. So these could, for example, help the mission control of the satellite to, for example, do the firmware encryption, and then there is another mechanism on board the satellite that accept these encrypted firmwares, performs all the critical checks that everything is okay, the firmware update should proceed, and meanwhile, attestation mechanisms may give information to the satellite operators that everything proceeds well, or something is not correct. For example, an attestation mechanism could identify that some portions of the firmware misbehave. So it could trigger early warning indicators to the operators, so they can take action.
Manolis, you are building something that can enable the transition to more secure and automated processes for enhancing the operational assurance of a satellite. How is that you're conducting your tests? Are you using some actual hardware trying to emulate real-world applications as much as possible?
Yeah, in our case, we use how it's called in our domain. It's called FlatSat. So imagine that CubeSats are quite compact in terms of space, because you try to fit many components into a small area, and you try to decrease the weight, because actually this is the main cost for the launch provider. So the commodity is $20,000 per kilo dollars. Huh? So you need to compress a lot of your subsystems. But on the other hand, this is a total nightmare in terms of debugging and troubleshooting. So during development of a satellite, we built a FlatSat. So imagine that this is an exploded view of the satellite, with different components placed on a bench, so you can access and troubleshoot them. So during the wire, we have built such a FlatSat with our communication board, that we call it Saturn Comms, that has an FPGA on board and an ARM microprocessors, two ARM microprocessors, and on board these we have integrated some of the REWIRE mechanisms. So yeah, actually we built the real thing.
Wow, perfect. So I will take you to the impact of REWIRE. So besides the obvious technical advancements, how else can REWIRE impact the satellite industry in terms of the type of research that we are doing?
Yeah, that's a nice question. So, as I mentioned before, we're targeting mainly the CubeSat satellite market because big satellites have already aspects for security, and they have done this for years. But now that the CubeSats are becoming more and more common, we expect more attacks on them, as also the telecommunication hardware that is required to talk with them is becoming cheaper. So in such missions, also the timeline is a critical thing. So most of them do not take into consideration at all the security aspect. So if REWIRE can, together with the mission control center integration, can provide security and a secure way of upgrading the firmware or testing the firmware on board or get an early warning indications and do it in an abstract way, so the operator does not have in mind all these technical aspects that are required for providing security. That could be a game changer for the CubeSat market.
Have you faced any challenges so far with REWIRE?
Yeah, of course. This is a very complex system, but all of such systems have many challenges. In our part, we faced challenges mainly with limited resources that CubeSats normally have. So yeah, but that's why we are here to deal with these challenges and proceed with the next step.
Manolis, are there any strategic exploitation avenues that you are targeting after the end of REWIRE for the proposed solutions?
Yeah. Actually, some goals that we have in the near future is to build a flying laboratory. So this will be a CubeSat that many customers or entities like universities, laboratories can access while in space, perform their experiments, and get the results. In such satellite that many can have access from multiple places around the Earth. Security is a critical part of the mission. So yeah, we would like to integrate some of the REWIRE mechanisms that we see that will play a crucial role in order to provide a safe and reliable satellite as a service to the customers.
And one final question from your perspective and your company's perspective. As one of the key players in satellites research, what does success for REWIRE look like for you?
From our perspective, as I mentioned before, it would be a reliable and trusted over-the-air update. For us is perhaps the most critical component that ensure the longevity of emission and removes a lot of stress from the emission operators. So if you know that you have a way to update reliably your satellite, it removes a lot of stress and also reduce the development cycles because time is one of the most precious resource. Especially in the satellite domain, you have very strict timelines and deadlines. So you deliver the satellite, and you cannot have access once you deliver it on the launch provider. Then it is in space, and you have no way to touch it or to fix something. So the only way to deal with issues is through software update. So for us, I think, and it is the most important contribution of REWIRE for us. It's the secure and reliable over the air update for the satellite.
Great. Manolis, thank you very much for joining me today and for all the insights and your input. I wish you all the best with your work in REWIRE. And
Thank you.
we might meet again in another interview in the future.
Sure.
So thanks a lot.
A lot.